Hello students, today we'll be learning in a whiteboard. We are dealing with the chemical, writing the chemical formula, so it is impossible to write to explain you in the videos, in the picture videos. So let's go in it and watch. So hello students, class 9, we are proceeding to chapter number 3, and we have already discussed about the atoms, the atomic mass, and molecules of the element, and molecules of the compound. And also we have discussed about what is an ion, and today we will be discussing about the most important topic in the chemistry, that is called writing chemical formula. Okay, we'll discuss about the writing chemical formulas. Okay, you see, writing chemical formula is one of the most important and one of the most backbones of this chemistry. Okay, so once if you don't know how to write the chemical formulas of any element or any compound, that become very difficult to learn the chemistry. Okay, so you see, a chemical formulas of the compound is just a symbolic representation. What is it? It is a symbolic representation. Okay, so if I want to represent the chemicals formulas of different element, okay, if I want to represent the chemical formulas of different element, we need to first learn the symbol of an element. We need to first learn the symbols of an element and the combining capacity of an element. Okay, we need to first learn the what? We need to first learn the symbols of the element. Now the example is what? If the element is hydrogen, okay, if the element is hydrogen, and we have to know how to represent the hydrogen in the form of symbol. The symbol is what? The hydrogen, the symbol is what? It is capital H. Okay, the hydrogen is derived from the English word. That is why we are representing this hydrogen with the first letter of that name, that is H, and we have to write the first letters, that is H, as a symbol. Okay, so hydrogen is represented H. Now when you talk about the helium, okay, so helium we represent by what? We know that how to represent it. We know that is He. Okay, we know that is He. So before we go to this, we'll first learn the 20 elements. Okay, we'll first learn the 20 elements. This is my tricks to learn the 20 element. Okay, this is my simple tricks to learn the 20 element. Hydrogens, helium. Okay, I'm sorry. So let's try to write in this sentence: hydrogen, helium, Libef, Sinofni, Namga, Alsai, PS, Chlor, Keka. Okay, so you see, this is how in this sentence, okay, in this very sentence I have 20 elements. From the atomic number 1 to the atomic number 20. I have 20 elements. You try to recall this. Okay, you try to follow me. That he, okay, he, okay, he libef sinofni namga alsai, ps clear, psar, okay, psclar, clear, okay, keka. Okay, what is it? So first letter is the H, that is hydrogen. We know that H is a hydrogen. H stands for hydrogen. And the second letter, that is He, that is helium. What is it? Helium, He, that is helium. Then lithium, Li, that is lithium, lithium. Beryllium, okay, Berylium, beryllium. Okay, so beryllium. So Berylium, beryllium. Boron, okay, B for boron. You see, so here you see, here He, that is H, double He. The first H stands for hydrogen. Second He, so second word H, and then small letter we have He stand for helium. Then Li lithium, Be beryllium, B boron. He libaf, okay, he libaf synopny, okay, synopny. C stand for carbon, and N stand for nitrogen, okay, N stand for nitrogen. Then you know O, capital O stand for what? Oxygen, okay. N stand for nitrogen, and capital N stand for nitrogen. O stand for oxygen, okay, and F stand for what? Fluorine. And N, and then we have small letter that is E, okay, that is one letter, one element. Ne stand for neon, okay, Ne stand for neon, okay. So we have how many element now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 element. He libaf synopny. He for H for hydrogen, He for helium, Li for lithium, Be for beryllium, B for boron, C for carbon, N for nitrogen, O for oxygen, F for fluoride, Ne for neon. Okay, so we have 10 elements in this sentence. Okay, try to read together again. He libaf synopny. Okay, so we have 10 elements now. Let's try to see again another 10 elements. Okay, another 10 elements. What is it? Another 10 elements, and all these 10 elements are in the form of sequence. 1, 2, 3, 4. Like we have a roll number in our class. Okay, this element also have their own roll number, and we don't call them as a roll number. Instead, we identify them as the atomic numbers. Okay, so they have their own atomic number. Atomic numbers of hydrogen is 1. Atomic numbers of helium is 2. Lithium is 3. Beryllium is 4. Boron is 5. Carbon is 6. 7. Nitrogen 8. Oxygen, fluorine 9, and neon 10. Okay, so we have a 10 element, their atomic number in a sequence wise. Okay, so you have to remember this. Okay, you have to remember this. Next we have a NAMGA. So NAMGA means Na is what? Na is a natrium, and this natrium is denoted by sodium. Na is what? Sodium. Okay, Mg is what? Mg is what? Magnesium. Mg is what? Magnesium. Mg is what? Magnesium. Then Al is what? Al is aluminium. Okay, Al is what? Aluminium. Okay, Si is what? Silicon. Si is what? Silicon. Okay, P is what? Phosphorus. Okay, phosphorus. Okay, so phosphorus. Okay, then S is what? Phosphorus. After that, S is what? It is sulfur. Okay, S is what? Sulfur. Cr is what? Chlorine. Cr is what? Chlorine. Ar is what? Argon. Okay, Ar is what? Argon. And K is what? Potassium. Okay, K is what? Potassium. Ca. C and then small letter A, that is calcium. Okay, so here's NAMGA, ALSI, P as clear, K K. Okay, let's read together. He libaf synopny, NAMGA, ALSI, P as clear, K K. Okay, so what is it? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Okay, so these are the 20 elements that you have to remember also. It is very much, if you start remembering the 20, we have total 115 to 118. In some books you will get 115, and some books you will get 118. Okay, so they have, in the universe we have nearly 115 to 118 element. Okay, we have 115 to 118 element, and all these elements are arranged in a sequence. Okay, and that sequence is what we call, according to that sequence is arranged. Okay, in the sequence it is arranged. Okay, and that sequence is what we call the atomic numbers of that element. Okay, atomic numbers of that very elements. Okay, I think you're clear about this one. Okay, so this is how the first thing is what? To write the chemical formulas To write the chemical formulas, you have to know the first thing is what? To write the chemical formulas, you have to know the first thing is chemical symbols. Okay, you have to know if iron is here, that means what is the symbols of iron? You have to know it is Fe. The first thing that you have to know the chemical formulas is what? To write the chemical formulas, you have to know the symbols of the chemical element. Okay, you have to know the symbols of that chemical element. And the second thing that you have to know is what? You have to know their valency. Okay, you have to know their valency. Okay, these are the two things. And what is that valency? Valency is known as a combining capacity. Okay, combining power. Okay, to combine with another element, what is their valency? So this is what we call valency, is what we also call them as a combining power. Okay, if the combining powers of carbon is 4, that means the carbon will try to combine with 4 other elements. Okay, carbon will try to combine with 4 other elements. If the combining capacities of, or the valency of hydrogen is 1, that means what? Hydrogen can only combine with 1 element. Okay, if the oxygens have a valency of 2, okay, if the oxygens have valency of 2, that means oxygen can combine, he can take 2 other elements. He can combine with 2 other elements, or 2 elements of that two elements. Okay, so that is what it says. Okay, so combining it varies from it varies from 1, 2, 3 and 4 only. Okay, all the elements might be having 1, 2, 3 or 4 elements only. Okay, you might not get 5, 6, 7, 8. Okay, there is no 5, 6, 7, 8. Their valency varies from 1 to 4. Their valency varies from 1 to 4. If we talk about hydrogen, they have a valency 1, helium valency 2. Okay, lithium valency 1 again, beryllium valency 2 again, that way. Okay, different element. Carbon, they have a valency 4. Okay, carbon you will get a valency 4. Okay, again beryllium you will get a valency 2. Boron you will get a valency 3. Okay, in this way the valency varies from 1 to 4 only, not more than that. You won't get more than that. Okay, you won't get more than that 4. Okay, your valency will vary from 1 to 4. Keep it in mind. Okay, and what is valency? A valency is a combining power or combining capacity of an element. Combining capacity of an element. If I want to write the chemical formula of aluminum, how I'm going to write? We know the names of aluminum. This is your aluminum. We know that. We know what is it. But I want to write in the form of symbol. What is it? The symbol is the first letter will be capital and the second letter will be the small letter. And that Al stand for what? Al stand for what? Aluminum. The symbols of aluminum is L. Okay. I hope you have understood. Okay. Now let's discuss about this. Okay, let's discuss about the rules. Okay, let's discuss about the rule. Before we go to the rule, let's try to understand. Okay, let's try to understand some other things. Okay, in a very simple examples. Okay, you see, octobus have 8 octobus. Okay, octobus have 8 hand, right? Octobus have 8 hand, and we human have a what? We human have a 2 hand, right? So let's say this is an octobus. Let's say this is an octobus. 1, 2, 3, 4, 5, 6, and 7 and 8. Okay, this is 8 hands of an octobus. Let's say this is an octobus. We have an 8 hand of an octobus, and if this said, let's say the octopus is denoted by letter O and the human is denoted by letter H. Okay, how we are going to write the element of this? Now let's say human octopus have a capacity of, he can hold how many he can hold? He have a, that means he can hold 8 stuff, right? But if I combine this octopus and human together, then what even? This one human can hold the hand of, hold the 2 hand, because he have a 2 hand out there. That means he can hold 2 hand of the octopus. The another one can hold again 2 more hand. Another one can hold again 2 more hand. Okay, 2, 4, 6. Again, another one can hold another 2 more hands. That means how much human are being in this. Human can hold 2 hands, another human can hold 2 hands. That means how many human does it use? How humans have been? 4 humans have been used. And how many octopus? Only 1 octopus. Then we will cross this side. We will cross this side. Okay. So your answer will become H1O4. Okay. So what is it? We can write H1. We can remove. So your answer will become HO4. Okay. So if you don't write 1 also doesn't matter. So this is how we represent. Okay. So this valency, you have to know the valency of every element. Okay. Combining capacity of every element. Combining capacities of every element. Okay, so first of all, you see, whenever we are going to write the chemical formulas of any element, whenever we are going to write the chemical formulas of any element, okay, the first rule, okay, the first rule is what? You have to know the valency of the element. Okay, valency of the element. Valency of the element. The first thing is what? You have to know the valency of the element. Second is what? Whenever you are writing, if there is 2 element, okay, if there is a 2 element, okay, if there is a 2 element, the first one we have to write whether that element, first element, the first name will goes to, the first priority will goes to the metals or metals ion, okay, and the second priority, second and the first element, whenever you are writing, let's say, to make it more clear, you see, okay, always metals written in the first. Okay, metals is always written in the first. Metal is written always in the first part of the name. Okay, first part, and then followed by non-metals. Okay. That means what you see, when you talk about the sodium chloride, okay, what is it? Sodium chloride, okay. So whenever we say actually sodium chloride, we can write this chemical formula as NaCl, right? This Na, sodium is a metal, sodium is a metal, Cl is a chlorine. Chlorine is a non-metal. Okay, chlorine is a non-metal. When they combine, we add this non-metal by IDE. Okay, we add non-metal by IDE. If you talk about the sodium magnesium oxide, okay, magnesium oxide. Okay, so if they are in the oxygen is in the form of combined, then we write this as IDE again, right? That means IDE denote that the are in the form of combination form. That means they are in the form of compound. That oxygen is in the form of compound. But if the oxygen is not in the form of compound, we simply write this as the oxygen. Okay. But if oxygen is a combined form, then we write the letter ending with the IED. Okay. So similarly again, if you talk about the carbon dioxide, okay, IDE again there's, okay. So whenever the metals, whenever the non-metals combine with another metals, mostly the word will be ending with IED, okay, which indicated that the elements are in the form of combination step. Okay. So you see, the first thing is that whenever you're writing, always you see NaCl. Okay. So this is always the first priority is given to the sodium, the first priority is given to the metal, and then we will write the non-metal, and then we will write the non-metals. Okay, so if you talk about the element, let's say X, element is A and B. Okay, A and B, element is the compound chemical name is A and B. That means the first letter A belongs to the metals, again second letters belong to the non-metals. Okay, non-metals, that you have to remember. This is our second rules. Okay. Our next rule is that, okay, if there is a polyatomic ion like carbonate, okay, so polyatomic ion like carbonate, if this is a polyatomic ion, if this is what we call, there's 3 atoms out here, 3 atoms out here, 3 atoms of oxygen out here, and 1 atoms of carbon dioxide, that means that is what we call polyatomic ion is there. Ion is present, that is what we call polyatomic ion. And if such a case is present, let's say it is combining with the calcium. Okay, so when we write calcium. Okay, so your calcium will be 2 plus. Okay, so calcium is 2 plus. So what we write here is, okay, so how do we write it, this types of element that we use to write the polyatomic always inside the bracket. Okay, if I want to write this polyatomic, that means every time remember that polyatomics are represented in, always read it in the form of bracket, inside the bracket. Polyatomics are always polyatomic ions are written, okay, written inside the bracket. Okay, always inside the bracket. Okay, polyatomic ions are always written inside the bracket. You have to remember the first thing is what you have to know, the valency of the element. Valency of the element, that means a combining capacity of an element. What is valency? A valency is a combining capacity of an element. The second is whenever you are writing the compound, whenever you are writing the chemical formulas of any element, okay, the first part is always a metal and the second part is always a non-metal. That means what? In the left side you will always find a metal. On the right side that element will be a non-metal. You talk about the NaCl. Okay, I have talked about the NaCl also. The left side it is the first part from our side. The first part of the left side it is always a metal, and the left side it is always a right side it is always a non-metal. Sodium is a metal, chlorine is a non-metal. So this is the second rule. And the third rule is what? If there is a polyatomic which is undergoing a chemical reaction, okay, that means always we have to represent under the bracket. And if there is a represent under the bracket, remember that this is a polyatomic ion. Okay, let's get into it. You see, let's try to write. Okay, let's try to go and try to solve some problems on your exercise. That will be more easier for you to understand. First of all, let's try to understand the examples. Okay, let's try to understand the example. The first thing is what? Hydrogen chloride. That is given in your example also. Okay, the hydrogen chloride, there H is what we represent hydrogen, and chloride, that means it is the chlorine that represents Cl. Okay, the valency of the hydrogen is always 1 and the valency of the chlorine is also 1. Okay, the next step is what? After we have written it, okay, then we shall do is that we'll try to cross this element in this direction and we'll try to cross this element. That means what? We'll write H1 here and Cl1 here. Okay, so 1 we don't, in a new mathematics also you know that 1 we don't use to write it. Even if we don't write the 1, we still consider that there is a 1 out here. Okay, so what shall we write here? HCl. Okay, that means if I remove this 1, that means our answer become HCl. Okay, so that is what we represent, HCl. Hydrogen chloride is what? HCl. Okay, hydrogen chloride is what? HCl. Okay, next again we are going to write the hydrogen sulfide. Okay, hydrogen sulfide. If you want to know the valency of any element, you can also go to the page number. You can also go to the page table number 3.6, page number 39. Their symbols and their valency is already given out there. Okay. Second is what? Hydrogen sulfide. Hydrogen sulfide. If I want to write the hydrogen sulfide, we know that hydrogen is represented by H. Sulfide means sulfide is represented by S. Okay, hydrogen sulfide. Okay, the valency of hydrogen is 1 and the valency of sulfide is 2. The valency of hydrogen is 1, the valency of hydrogen sulfur is 2. Then I will cross this one and then I will cross this one. That means I can write this one as a H. After that I will multiply with hydrogen, and then S I will multiply 1 with this. So 1 we don't write, so simply our answer will become S2S. Okay, this is what? Hydrogen sulfide. This is what? Hydrogen sulfide. The second thing is what? Our second thing is what? Our second thing is what? We are going to write the name called carbon tetrachloride. Okay, carbon tetrachloride. Carbon tetrachloride. Carbon tetrachloride. Okay, so carbon is what? Carbon is 4. Carbon is C. Chloride is Cl. Okay, tetra is numbers. Okay, tetra is just a numerical numbers. Okay, this is a numerical number. Tetra means it is 4. Okay, tetra is just a 4. So we only find out what is element present out here. Carbon tetra is not an element. So carbon C, chloride, that is chlorine, that is Cl. Okay, so here we write this one as a carbon tetrachloride. The elements of carbon is the valency of carbon is 4 and the valency of chlorine is 1. Then carbon will go this side, 1 will go this side, chlorine will go this side. So our element will become what? C1Cl4. Okay, so this is our answer, that is CCl4. Okay, CCl4. That means what? Carbon is combining 4 chlorine. That is why you say carbon tetrachloride. Tetra means you see Cl4 means what? Carbon is combining 4 other chlorine. That is what you call carbon tetrachloride. Okay, so similarly, if I go and write down the next formulas that is given in your example, okay, I have write this one in your textbook. It is already given. That is question number 1. Sodium oxide. The question number 1 is what? Sodium oxide. Sodium oxide. Okay, sodium oxide is what? If it is a sodium oxide, then what shall we write here? Okay, so sodium oxide, what is it? Sodium we know Na, and oxygen we know O. Okay, the valency of sodium is 1, the valency of oxygen is what? 2. So I will cross these two. Okay, I will cross these two. This is your exercise 1, page number 41. Okay, exercise question number 1, sodium oxide. Then 1 I will go this side. Okay, so Na will go down, Na I will write with 2, and then oxygen will be written with 1. So our answer will become what? Na2O. Okay, so this is how we write Na2O. Okay, so next again we are going to write the next questions. Okay, next question again, aluminum chloride. Aluminum chloride. If I want to write the aluminum chloride, okay, aluminum chloride. Okay, so aluminum chloride, what is it? Aluminum chloride. Aluminum chloride. Al is your aluminum, chloride is Cl. Okay, so aluminum have a valency of 3 and a chloride have a valency of 1. Aluminum have a valency of 3 and a chloride have a valency of 1. Aluminum have 3 and chloride have 1. Okay, so I will cross this one and I will cross this one. So what is our answer? Al1Cl3. So our answer will become AlCl3. Now just remove the 1. Okay, so if I don't want to write the 1 also, doesn't matter. Okay, next again I will write the sodium sulfide. Okay, sodium sulfide. Sodium sulfide. So I will just write this side, sodium sulfide. Sodium sulfide. Sodium sulfide. Okay, sodium sulfide. Sodium sulfide. Okay, sodium sulfide. What is it? So our element in sodium sulfide is what? So what is it? Sodium is Na, sulfide is S. Okay, I already told you from the very beginning that sulfide has a valency of 2. Okay, sulfide has a valency of 2, sodium is 1. Then intercross it, Na2S. Okay, Na2S, this crossing and this crossing. Okay, so this is how we write the numerical chemical formulas of the equation. So in this way you try to write it down the remaining questions. Okay, and this way you try to solve it the numerical questions and try to submit the notebook in the schools. Okay, anyway, this is the this is the how we write the chemical formulas. If any numerical any problems here, you can call up and discuss with me so that we can discuss more in details. Okay, so in the next video lectures we will discuss about the molecular mass and the mole concepts. Okay, molecular mass and the mole concept, and then yes, mole concept, molecular mass and mole concept will be the last topics for these chapters. Okay, so anyway, stay safe. Bye bye.